Welcome to this comprehensive tutorial on C# events, a fundamental concept for building robust and interactive applications, especially crucial for game development and responsive user interfaces. C# events are a powerful mechanism that allows different objects within your application to communicate with each other in a highly flexible and loosely coupled manner. They are fundamentally based on the well-known observer design pattern, where one object, the publisher, notifies other interested objects, the subscribers, when something significant occurs. This design pattern ensures that the publisher doesn't need to know the specifics of who is listening or how they will react, promoting a highly modular and extensible architecture. Such flexibility is incredibly valuable in various programming scenarios, from handling user interface interactions to managing complex game logic. Events allow for a clean separation of concerns, making your code easier to understand, maintain, and scale as your projects grow in complexity. Let's begin our practical journey by understanding how to declare an event using delegates within the Visual Studio environment. The first step in declaring an event is to define a delegate. A delegate acts as a type-safe function pointer, specifying the signature that event handler methods must match. This delegate essentially defines the contract for any method that wishes to respond to our event, ensuring consistency in how event data is passed. For events that don't pass custom data, the built-in event handler delegate is commonly used, often paired with event args for standard event information. If you need to pass specific data with your event, you'll use event handler TEventArgs, where TEventArgs is a custom class inheriting from event args. After defining the delegate, we declare the event itself using the event keyword, associating it with our chosen delegate type. This event keyword is not just syntactic sugar. It provides important compiler-level protection, restricting how the event can be used. Specifically, it prevents external code from directly invoking the event or clearing all its subscribers, ensuring only the declaring class can raise it. Now that we've declared our event, let's explore how other objects can subscribe to it, allowing them to react when the event is raised. Subscribers attach a method, known as an event handler, to the event using the += operator, effectively adding their method to the event's invocation list. This event handler method must precisely match the signature of the delegate that was defined for the event, including its return type and parameters. If the signatures don't match, the compiler will issue an error, preventing you from incorrectly subscribing to the event. It's absolutely crucial to unsubscribe from events using the -= operator when the subscriber object is no longer needed or is being destroyed. Failing to unsubscribe can lead to memory leaks, where the publisher still holds a reference to the subscriber, preventing it from being garbage collected. This can cause unexpected behavior and performance issues, especially in long-running applications or games with many dynamic objects. Finally, let's see how to raise an event, which is the action that triggers the notification to all currently subscribed objects. Events are typically raised from within the class that declares them, often in response to a specific internal action, state change, or external input. It's considered a best practice to check if there are any subscribers before invoking the event, using the null conditional operator (?). This simple check prevents a null reference exception from occurring if no objects are currently subscribed to the event when it is raised. When raising events that use event handler TEventArgs, you'll typically pass this as the sender in an instance of your custom TEventArgs class. Now, let's put these concepts into practice with a simple C# console application example to solidify your understanding. We'll create a button class that simulates a UI button. This class will declare and raise an onClick event when its click method is called. Then, we'll create a display class that will act as a subscriber. It will contain a method, handleClick, designed to respond to the onClick event. In our main method, we'll instantiate both the button and display classes, then subscribe the display's handleClick method to the button's onClick event. Finally, when we invoke button.click, the display class's handleClick method will automatically execute, demonstrating the event flow in real time. This simple console application clearly illustrates the publisher-subscriber model in action, providing a foundational understanding of event-driven programming. Next, we'll explore a more dynamic and practical application of C# events within the Unity 3D game engine, where they are indispensable. Events are incredibly useful in Unity for decoupling game logic, allowing different game systems to react to player actions or game state changes without direct dependencies. Consider a common game scenario. A player collects an item. This single action might need to update the UI, play a sound effect, and increment the player's score. Instead of having the player script directly reference and call methods on the UI, audio, and score managers, we can use an event to notify all interested parties. Using a static event makes it easily accessible from anywhere in your code without needing a specific instance of the player controller. When the player character's onTriggerEnter method detects the item collection, the onItemCollected event is raised. Now, separate scripts for the UI manager, audio manager, and score system can independently subscribe to this single onItemCollected event. Each subscriber implements its own specific logic in response to the event, such as updating a text field, playing a sound, or modifying a score variable. This approach keeps our game code modular and incredibly easy to maintain, as changes to one system don't directly impact others. For instance, if you decide to change how the score is displayed, you only modify the score manager script without touching the player controller or UI manager. Throughout your development journey, remember these helpful tips and best practices for working effectively and safely with C# events. Always use the event keyword when declaring events. This is not optional. It's a crucial safeguard provided by the C# compiler. It prevents external code from directly assigning to the event or invoking it, ensuring that only the declaring class can raise the event. Prefer Event Handler, TEventArgs, for events that pass custom data, as it provides a standardized and type-safe pattern for event arguments. Remember to unsubscribe from events, especially in Unity's onDisable or onDestroy methods, to prevent memory leaks and ensure proper object lifecycle management. For static events, be extra diligent with unsubscription, as they persist throughout the application's lifetime and can easily lead to leaks if not managed. Consider using action or func delegates for simpler events that don't require custom event args or specific naming conventions, offering a more concise syntax. Adopt clear and consistent naming conventions for your events, typically starting with on followed by a descriptive name, like onPlayerDied or onScoreChanged, when handling events. Ensure your event handler methods are robust and can gracefully handle potential errors or unexpected data. C# events are a cornerstone of clean, maintainable, and scalable C# applications, particularly in complex systems like games and large-scale enterprise software. By mastering event declaration, subscription, and raising, you'll significantly enhance your programming toolkit and build more responsive and flexible applications. We hope this tutorial has provided you with a solid foundation for using C# events effectively in your projects. Thank you for joining us, and happy coding!